Okay, so the question is, which of the combinations will not produce any precipitate? The concentrations shown are after mixing but before reaction. So we're given four choices, and so for the first, if you look at the first one, A, we see that the KSP for Cu2S is given. So that reaction is Cu2S goes and dissolves into Cu, and the 2 goes in front of it because there are 2 of them per S, 1 S, and here's the KSP. So we're given these concentrations. So this compound, we know from our solubility or rules that nitrate is going to completely dissolve, and actually all these will completely dissolve. So we can just think of the concentration of CuNO3 as just the concentration of Cu, because it's going to completely dissolve. So the concentration of Cu is 4.05 times 10 to the negative 16, and the same thing here, 1.75 times 10 to the negative 16. So we know that, so we're going to calculate for Q. We know that Q equals, this is a solid, let's not forget, so this equals the concentration of Cu, and we square it, and then we multiply it by the concentration of S. So this equals that concentration squared multiplied by the concentration. Squared 7.5 times 10 to the negative 16. So if we plug that into a calculator, so the answer is Q equals 2.87 times 10 to the negative 47. So we need to compare this with the given KSP for the reaction. So we notice that at Q, when we mix these two solutions, this is the starting position. It's 2.87, and it needs to go to equilibrium. Equilibrium is 2.0 times 10 to the negative 47. So since 2.87 is larger than the equilibrium, it means you have to have less. The reaction needs to go to the left, because we have too much product, right? We multiply the concentrations and we get some number, 2.87, and it's bigger than the equilibrium. So what's going to happen is that this reaction is going to move to the left to decrease the concentrations. Once we decrease the concentrations, the concentration of Cu squared times S should equal the KSP given, because that's at equilibrium. So right now we're not at equilibrium, it's larger. So the reaction is going to go this way. And when it goes that way, it's going to precipitate. This is precipitate, this is solid. So this will precipitate. And the question says, which of the combinations will not produce any precipitate? So that's not the answer. So we need to move on to the next one. For B, if we look at the given reaction, it's Ag2, and then so we have Ag2CrO4, and that's going to dissolve into 2 Ags plus that. So we know that Q is going to equal pretty much same thing, similar to the first one. So I'll just plug in that really quick using the concentrations given. So 5.32 e to the negative 4 squared multiplied by 4.48 e to the negative 5. So that gives us 1.26. Again, this is larger than the KSP at the equilibrium. So this is going to move to the left, so it's going to produce precipitate. So that doesn't work either. So A doesn't work, B doesn't work. Let's look at C. C is P, B. I'm just going to copy this down. P, 4. That is going to go towards 3 PB plus 2 PO4s. Right. So we know that Q is going to equal the concentration of PB cubed multiplied by phosphate squared. So I'm going to just calculate that really quick. So 2.79 e to the negative 3 raised to the third power, multiply that by, so raised to the third power and raised to the second power. So 2.7 raised to the third power and 1.38 raised to the negative 9 to the negative 9 squared. So the Q that we calculated is 4.14 times 10 to the negative 26. Now this number is smaller than what's given, which is 3.16 times 10 to the negative 44. So since this is a larger number. So since this is larger, it's going to move to the left, so it's going to precipitate as well. So that one doesn't actually work either. That doesn't work either. It's too large. The number is larger, so it's going to move to the left. So I assume that this has to be the final one. It's basically just NAI, and NAI moves to Na plus I. So the Q should just equal the concentrations of these two. So it's the first one multiplied by the second one. So you multiply the exponent, is going to give us a very small number, and it's compared to that. So it's going to be smaller, so it's going to precipitate. And we can just do it quickly. 1.18 e to the negative 3. And we multiply that by 8.49 e to the negative 15. So negative 17. This is clearly much smaller number than 1.41 times 10 to the negative 8. Because it's smaller, the concentrations here are too low compared to what they need to be at the equilibrium. So these will have to, is that right? So we said Q equals 1.0 times 10 to the negative 17. So this is small. So these have to increase. So what happens is that this reaction is going to go this way because there's not enough. At equilibrium, this number should be 1.41 times 10 to the negative 8. And this is far from it. So it's going to have to go this way. So whatever precipitate we have, it's going to need to dissolve to reach equilibrium. So this should be the answer. We can just check it to make sure. So that's the last one. Negative 8, we calculated the concentration to be negative 17. 15 plus 3, and you take into the consideration this multiplication. So let's check the answer. And this is, congratulations, that's the correct answer. So that's how you solve for that problem.